Hi everyone, welcome back. So now let's actually practice drawing a free body diagram together, okay? We're going to draw a free body diagram. So first off, what's our situation? Okay, well, we got here is we have a beam, it's pinned at the wall. We have a cylinder that's sitting on top of it, okay? There's a point at D, a point at C. Well, this all makes sense. So how many free body diagrams do you think we're going to have here? Well, actually I'm going to leave it like this for a second. It depends what you want to know. If you want to know this force at D, then you're probably going to have to solve everything. Just looking at D is not going to be enough. Each individual physical object, like this beam, it's got a physical size. The cylinder is going to be a separate free body diagram. If they're physically attached, like they're bolted or welded to each other, it's one free body diagram. But if they're just sitting on top of each other, you can have separate free body diagrams. You don't have to, you can do it all as one cohesive whole, but you can have separate free body diagrams. And so that's what we're going to do in this particular case. So let's see, I think I do the beam first. So let's look at this beam. So first off, I cut it away from everything. So cut, I get it off this, I cut it off the wall, and I draw it by itself. Now every place I cut, I need to add a reaction force. Some sort of force. Now I said, okay, cut a cable, so I draw an arrow from the object towards where I cut. Then this surface right here, it's a roller on top of it, so that can only be a perpendicular force somewhere at C. And then I've got a pin connection to the wall, which will give me a reaction force in the X and the Y direction. Okay, so 1, 2, 3, 4. 4 unknowns. If I knew more about it, I could probably solve this. Now let's check myself and see how I did. So I've got my tension right here from the wire. I have my reaction force in the Y, my reaction force in the X, my force from that cylinder, and we're good. And up, one force that I forgot, thank goodness it showed it to me, is the weight. This rod has a weight, and I forgot to include that. And here are all those given names. Because I don't necessarily know any of them right now, I have to give them names. Usually what you do is you say if it's a force, well, you put a force, and then you put a subscript which is saying where it comes from. You might add a further subscript to say if it's in the X or Y direction if you know that. I would also need to add in an angle to help myself out here. Saying, well, this angle 2 right here is from the vertical, this theta 1 is from the horizontal, so I know what direction those forces are going. And that's a pretty good free body diagram. Okay, let's look at it again, but this time we're going to focus on the cylinder. So I'm going to draw it over here. I'm going to do better this time. It's a roller. It's touching things at 2 places. So it's got a force here at the wall, a force right here from my beam pressing up on it. If you're confused because earlier you saw, wait a second, wasn't the force going that direction earlier? It switches. For the beam, it's going down and to the right. For the cylinder, it's going up and to the left. You can just kind of think of it like a dimension line. The arrow, depending on which side it's touching, will be opposite. And of course, it's going to have a weight. Okay, that should do it. I think I got it right this time. Let's look. So I got that. Have my forces, have my weight. All is well. And I might want to once again add in an angle to help myself out here. So that will be it for this time, just giving you an example of how we draw a free body diagram. I hope this helps you. This is definitely a skill you need to master. Okay, it's definitely a skill you need to master, and you're going to get plenty of practice, I promise. So thank you for listening, and I'll see you all next time. Have a wonderful day. Bye-bye.